Ever wondered what carbohydrates are and why they are so important to our bodies? Let's dive into the mystery of carbohydrates. At their core, carbohydrates are organic substances made up of three simple atoms: carbon, hydrogen, and oxygen. These atoms arrange themselves in a ratio of 2 to 1, just like in water, resulting in the general formula seen, H2O, N. But there's more to carbohydrates than meets the eye. They also contain functional groups, special groups of atoms that have specific chemical behaviors. Picture the alcoholic hydroxyl group with its characteristic O, or the aldehyde group, standing out with its CHO. And let's not forget the ketone group with its distinctive C=O structure. These functional groups play a crucial role in defining the properties and reactions of carbohydrates, making them an essential part of our dietary intake. So carbohydrates are not just about energy. They are complex structures with a variety of functions. But did you know that not all carbohydrates are the same? Carbohydrates, these organic substances composed of carbon, hydrogen, and oxygen atoms, can be quite complex. They are classified in several ways, but let's dive into the classification based on complexity. This categorization breaks carbohydrates down into monosaccharides, oligosaccharides, and polysaccharides. Monosaccharides are the basic units of carbohydrates, and these simple sugars cannot be broken down further by hydrolysis into other simple sugars. You've probably heard of some of the most common monosaccharides like glucose, fructose, and galactose. Oligosaccharides, on the other hand, are composed of 2 to 10 simple sugars. Polysaccharides, the most complex of the carbohydrates, contain more than 10 simple sugars. So, when we talk about carbohydrates, we're actually referring to a wide range of substances. So, when we say carbs, it could mean anything from a simple glucose molecule to a complex polysaccharide. Now let's delve deeper into the diverse world of carbohydrates. Carbohydrates are classified on the basis of functional groups into two types: aldose and ketose. Aldoses contain an aldehyde group, giving them the ability to reduce other substances. Ketoses, on the other hand, contain a ketone group, but the classification doesn't stop there. Carbohydrates can also be classified on the basis of their reactivity into reducing and non-reducing sugars. Reducing sugars have the ability to donate electrons or reduce other molecules, which makes them quite reactive. Non-reducing sugars, on the contrary, do not have this property. From these classifications, it's clear that carbohydrates are not just simple sugar molecules. They are complex structures that play varied roles in different biochemical reactions. So the next time you hear carbs, remember it's not just about bread and pasta. It's a whole world of diverse molecules with varied functions. So, what have we learned about carbohydrates? Well, we've untangled the complex world of these organic substances, made up of carbon, hydrogen, and oxygen atoms in a ratio of 2 to 1 as found in water. We've delved into their functional groups, ranging from the alcoholic hydroxyl group, the aldehyde group, to the ketone group. We've also ventured into the three ways carbohydrates are classified based on their complexity, functional groups, and reactivity. We've discovered that monosaccharides are simple sugars, the basic units of carbohydrates. Oligosaccharides consist of 2 to 10 sugars, while polysaccharides contain more than 10. We've also learned that they can be aldoses or ketoses based on their functional group, and reducing or non-reducing sugars based on their reactivity. So, carbohydrates are much more than just food. They are complex, diverse, and crucial to life on Earth. Remember, every carb has its story.